be seeing the quick recap of carbon and its compound. So first let us know the sources of carbon. So we all know that carbon is present in a very limited amount in the atmosphere as well as in the Earth's crust. But we use lot of carbon compounds and we are also made up of carbon compounds. So what are the sources of carbon compounds? It's present in animals, plants, even the dead and decayed organisms are also containing carbon compounds. So we can see a lot of examples here. And the fruits that we eat, the cosmetics that we use, and the aromatic compounds, and even the cellular compounds, everything is made up of carbon compounds. So totally there are 3 million carbon compounds in the world. So let us know more about carbon. So carbon, we know the symbol is C and atomic number is 6. So you can see the electronic configuration here. In the first shell, that is K shell, you have 2 electrons, and in the L shell you have 4 electrons. So the valency is 4. So now let us know what carbon is doing to make so many compounds. So how it is making a bond, or how it is just combining with the other elements. So we know that the outermost shell contains 4 electrons and there are 6 protons because the atomic number is 6. So now if carbon gains 4 more electrons to satisfy the octet structure, that is 2, 8 will be the structure. If it gains, what happens? It cannot, that is the 6 protons cannot hold 10 electrons. So C4 minus anion cannot be formed. Now the other case is if carbon loses this 4 electron to satisfy the duplet structure. See, if it loses this 4 electron and if it satisfies the duplet structure, the carbon does not have energy to lose 4 electron. So C4 plus cation is also not possible. So what carbon is doing to form so many compounds? Either it should lose or it should gain, but it cannot do both. So like you can see one example, that is chlorine molecule. See, the 1 electron is shared by the chlorine molecule. In the same way, carbon also shares electron. So these are the few examples of covalent compounds, that is the electrons are being shared by the atoms. You can see some example here, that is hydrogen, chlorine and methane, and this is a water molecule. So now carbon compounds are covalent compounds. What is covalent compound or covalent bond? Covalent bond is a bond that is formed by sharing of electrons. Remember CS. As I told you before, remember IT for ionic bond, that is ionic bond is transfer of electrons. Remember CS, there is covalent bond, sharing of electrons by the atoms to gain the stable octet structure. So 6 protons cannot hold 10 electrons, so C4 minus anion is not possible. In the same way, carbon does not have energy to lose 4 electrons to satisfy the duplet structure. So C4 plus cation is also not possible. So carbon shares electron to form covalent compounds. Now what makes carbon so versatile? Why? Though it is present in a very minimum amount, it has 3 million carbon compounds. So there are 3 unique properties of carbon, that is catenation, tetravalency and isomerism. Let us see one by one. So what is catenation? The self-linking property of carbon by the covalent bonding. What is the meaning of self-linking? That is, each and every carbon will link to itself. So there are many carbon atoms in a same compound. So self-linking property is called as catenation. See, it can be linked in the straight chain, it can be in the branch chain, and it can also be in the closed chain. There is a ring structure. So catenation is possible in 3 different ways: straight chain, branch chain, and closed chain. So you have one more element that also shows the property of catenation, that is silicon, but not to the extent of carbon. And the next property, there is a next versatile nature, is tetravalency. Valency of carbon is 4. It can be bonded with 4 monovalent atoms. So you remember the structure of methane, right? CH4. So the 4 sides hydrogen is bonded. In the same way, it can be 2 hydrogen, it can be 2 chlorine, it can be 4 chlorine, or it can be 3 hydrogen and 1 chlorine. So any 4 monovalent element or atom can be bonded to 1 carbon atom. And the next property is isomerism. So isomerism is a phenomena in which a compound have same molecular formula but different structural formula. So the molecular formula will be same and it exhibits different structure. So there are different types of isomerism, like structural isomerism, functional isomerism. So let us see the simple example of one structural isomerism and functional isomerism. So these compounds exhibit isomerism, so they are called as isomers. So you can see one structural isomers, that is butane. See, there are 4 carbon atoms here in the straight chain, and here also 4 carbon atom but in the branch chain. So the molecular formula C4H10 is same, but the structure is different. In the same way, you have pentane, that is isopentane and neopentane. There are 3 possible isomers for pentane. Next one is functional isomers. So functional groups will be different, but the molecular formula will be same. You can see 4 carbon atoms here, 1, 2, 3, 4, and here also same 1, 2, 3, 4. And if you count hydrogen, it will be 8. Here if you count hydrogen in butanol, it will be 8. So you have C4H8O, the molecular formula of this butanol as well as butanol. So the structural formula is different. In the way, the functional group is different, but the molecular formula is same. Now let us move on to the next topic, that is allotropes. We know that there are many allotropic forms of carbon, out of which diamond is a famous one, and we use graphite, we use diamond. But both have the same elemental formula, that is carbon, but the structure is different and the property is also different. Let us see more about allotrope. So what are allotropes? Structurally different form of same element. What is the same element here? Carbon. Why this allotropy arises is because of the small size and the valency. So you can see how the properties will be. See, chemical properties are same. Chemically they are same as carbon, but the physical properties are completely different for allotropes. So there are main 3 allotropic forms of carbon: fullerene, graphite and diamond. So this phenomena is called as allotropy. Structurally different form of same element, it is because of its valency. So the physical properties are completely different and chemically we are same. Now let us see more about diamond and graphite. So diamond can be synthesized by subjecting pure carbon to very high pressure and temperature. So all the synthesized diamond will be small in size and the originally formed diamond will be bigger in size when compared to the synthesized one. So we cannot synthesize the bigger diamonds. So what is diamond? How the structure is? So diamond, it's a rigid 3-dimensional structure. So if you look at here, one carbon is bonded to 1, 2, 3 and 4 carbon. So this is a 3-dimensional structure. Here, one carbon is bonded to 4 different carbon atoms and there is single bond here. Now if you check graphite, it is in the hexagonal array. Here, if you check one carbon, just check this, one carbon, 1, 2, 3. Check here, 1, 2, 3. So this carbon is bonded to 3 different carbon atoms in the sense it contains one double bond. So in diamond, there is no double bond. In graphite, there is one double bond. This is a 3-dimensional structure and this is the hexagonal array. So this is the end of part 1 recap.